Welcome back to our Python learning series. In this video, we'll tackle more data types that every Python programmer should know. These more complex data types are crucial to understanding Python code, as this is almost always used in every project you would come across. By the end, you should be ready to use them in your code as well. Before we start, let's first review the first data types we learned in the first part. String, integer and float, which are both number values, boolean, which is either true or false, and none type. String is used to represent alphanumeric data. Int is used to represent numbers without decimal points. Float is used to represent more precise numbers with a decimal point value. Next, boolean is used for binary values, like a checkbox where the only states possible are true or false, checked or unchecked. And none type, used to mean a value is to be supplied or is null. Now let's examine the ones we covered, like my favorite number or favorite color. The current containers we know of can only hold single values. But what if we wanted our containers to represent something with multiple elements? What if someone, for example, had multiple favorite numbers or multiple favorite colors? What if we want to take note of our grocery shopping? Then the existing data types would not be enough for what we want. This is where a new data type comes in, list. This works by allowing us to create a collection of the data types together. For example, if we had multiple favorite numbers, it would look like this. And if we had multiple favorite colors, then it would be like this. Lists are ordered collections of items that can be of any data type we have discussed so far. To create a list, we initialize it with square brackets. Imagine the square brackets as our container for the multiple elements. Right now, with just the brackets, our container has no items. We can start adding values to our list by separating them with commas. Let's try to make a grocery shopping list here. Now with lists, we have many actions we can use to make changes or inspect the container. Methods or functions are what we call these actions, and the way we use them is to call their keyword. Let's try one. Let's say I want to find out how many items is in the container called groceries. To check out how many items are in our container, we use the len keyword, short for length, and by putting our container inside the parentheses like this. Now we know this list has 10 items. If we want to keep adding values to the bracket, we could use the append method. This instructs the program to add the element we put in the parentheses to the end of the list. Let's check it out. Lists are ordered elements, which means each value can be accessed by specifying in the code what we want using the value's order in the list. We call this its index. In most programming languages, we don't start the list by the number 1, unlike how we would normally do it in everyday things like grocery shopping lists. We start the order with 0 instead. To access the last element, we use -1. We can also expand this logic here. If we want to access the second to the last item, we do -2 instead, and so on. To access the first element of the list, we specify 0, like this. There are many more uses and methods for lists, but for now, let's move on to the other data type called tuples. Now, tuples are also similar to lists, and the way to initialize a tuple is just to comma separate the values. But for readability, commonly it is enclosed by parentheses like this. But how is it different? The most crucial difference of tuples is that once you initialize its values, there's no changing them. These are called immutable values. When we try to do it, the program will show an error. Take a look. So we use tuples if we don't intend to change any of the initialized values. It adds a layer of integrity for programs. Think of it as a list data type with extra features. The last one we'll be tackling is something called sets. Like the first two, it's also a collection of items. But what makes it different from the first two we tackled? Let's start with an example. I'll try to make a set of numbers and print it. To initialize a set with values, we separate the values with commas and enclose everything within curly brackets, like so. Now I want to print this with the values I inputted and also find out the length of our set. Take a look and examine the values that pop up. What do you notice? You'll see that not all of the elements I put in were reflected in the final set. Take a look at the values that were not included. It's because these values are actually duplicates of the ones entered in already. That's the use of sets. They are collections with no duplicate values. What's more is a set is not an ordered collection. That means it can't be accessed with indexes, just as how we did it with the first two. You might also notice that the values aren't arranged as when we initialized the set. So those are the three advanced data types we will tackle today. Alright, let's have a quick test. I have 6 lines of code here. Which line would not work and cause the program to throw an error? It's the 4th line. Let's run it. Remember that sets are not ordered and cannot be accessed by index. I have another one. Why does this code not work? And how do I fix it? To fix it, we would need to replace the whole tuple with a new value entirely. Remember, tuple values cannot be changed individually once they are already initialized. And there you have it. We've covered lists, tuples, and sets in Python. Each of these data types has its own unique features and use cases, so feel free to experiment and incorporate them into your Python projects. Thanks for watching. If you learned something, like the video and subscribe for more. Go to the comment section below if you have any questions. Until the next one.